Awesome. Well, welcome. Good morning or good evening, wherever you're at. My name's Jay. I work at DoorDash. If you're not familiar with DoorDash, we're a on-demand food platform that connects businesses with hungry customers. At DoorDash, I work on the production engineering team, but more specifically, I work on compute. So I do a lot of Kubernetes. But someone in DoorDash at some point figured out that I've been working with Terraform since 2015. So subsequently, I do a lot of Terraform stuff at DoorDash on a regular basis. Today, what I wanted to talk about specifically was code reviews, Terraform code reviews, and how we can supercharge them with Conftest. But before getting into what Conftest is and what I mean by supercharged, I wanted to provide a bit of background, specifically what a morning looked like for me a few months back. So let me do a quick play-by-play. I'm glad they did the intro with the coffee aficionado because this makes a whole lot more sense. So typically my morning would look like this. I would head downstairs for a quick double espresso. And then that double espresso would be quickly followed by an avalanche of pull request reviews in Slack, possibly infrastructure changes from the night before or possibly that morning. I would go through a few of them. I would give them a Slack checkmark emoji to let them know that I had approved them, and they would apply those infrastructure changes. Get some time, I would look at GitHub again, and it would be more unread notifications. I would go through those. I would approve some more PRs. And then I would follow it up typically with more coffee, this time a pour over. Basically, my morning was a lot like this. I would rinse, repeat, find some time to do some actual engineering, but I had solidified my role a few months back as basically a full-time pull request reviewer, which is not great. So segue into what we're going to cover because it's important to talk about how we got here and how we got away from that. In this talk, I want to cover basically what the evolution of Terraform looks like for most organizations. This evolution somewhat resembles what I've seen working with Terraform over the years, how Conftest fits into that journey, share a few real simple recipes that you can use that might get the gears going on your end to figure out like how you can start automating stuff, and then I sort of give a quick demo of what that looks like in practice. So let's dive right into this, into what a typical evolution of Terraform looks like for most. I like to break evolution of Terraform into three distinct eras. There's the works on my machine era, where all the ingredients you need to build infrastructure are there, but ultimately you have a chef or an engineer that puts everything together and wires some stuff together and I guess delivers infrastructure. There's the looks good to me era where there's some automation. You can think of this like a store-bought cake. It works, but it doesn't always taste great. And then there's this era of robots where we want to be, where basically everything's automatic and engineers are only doing the required amount of work, not anything additional. So when talking about these three eras, I like to show it in terms of how it impacts an organization. And the easiest way that I find to show this is agility versus stability. And typically the first step that most organizations end up in is this help wanted phase. You have a few folks in operations early on. They may not have like a pure operations background, and they might be doing something like managing all of their infrastructure by hand. They're literally pointing and clicking in the AWS UI. But ideally, nobody that's attending today is doing this because we're talking about Terraform. But no judgment if you do, because a lot of folks have been here before. And but for the sake of this talk, I just want to ignore this quadrant entirely. Just know that it's not very agile because it's super slow. It's at the pace of pointing and clicking, and it's not very stable because you don't know what anyone in your org is doing. Where I do want to start is this works on my machine era, which this is typically what a workflow looks like. An engineer opens their text editor. Maybe they want to manage a security group and they discover this really cool thing called Terraform for the first time. And they think, oh, I'm going to codify this. This is awesome. So they write some code locally and then maybe they apply it locally. And obviously there's some major downsides, which we'll get into later. But for the most part, it just works. And this is magic for someone who's never done infrastructure as code before. When they describe something in Terraform for the first time and they do a plan and see what's going to happen and then apply and then it happens, it seems like magic for most. The engineer just codified a security group, they planned it locally and it just applied and everything just worked. And it works for the most part up until it doesn't work. A lot of us know this, right? So someone else created a security group on another system, or maybe they created it in the console of AWS console, and you start seeing things like this. The security group already exists, where we go to apply. And so we know at this point that there's absolutely no clear consistency of our actual infrastructure and what we have in our config, or what our local state says. So most people wise up after experience this, and they say, I can fix this. This is a real simple fix. All I got to do is start sharing state with the rest of my org. In fact, Terraform has this really cool built-in feature called remote state. I can start utilizing something like S3 to store my remote state. Now all of our states are in sync. Terraform will always be using the latest copy of my state. Engineers won't clobber each other anymore. And we're going to ensure that all changes by everyone are always reflected. And that works for a bit as well. But then you start noticing things like this, where you have what you believe is the latest copy of the config, and you do your normal plan locally, and it pulls down the state, and it tells you you're about to delete a resource that you actually didn't know exist because you're not managing it. Well, it turns out that another engineer actually created that resource, but they forgot to push up the config. So when you ran a plan against your config, it said it was going to destroy a resource that wasn't being managed. So to sum up, the works on my machine mode, it has a handful of pros and cons. The pros being that making code/infrastructure changes is pretty easy, and engineers can just ship stuff for the first time. But additionally, that there's not much to implement here besides installing Terraform, getting some remote state set up in most cases. But there are a lot of cons. You can easily end up with this state config inconsistency where an engineer forgets to push something. And then there's this thing that we haven't talked about, which is there's a high risk that an engineer may inadvertently introduce a security risk because it wasn't actually approved, or maybe they accidentally do something silly like blow away a production database on their local system, something we definitely don't want to happen. Additionally, there's absolutely no accountability, no audit trail, no story of who did what and when, and there's little to no collaboration. So it's really not that great. So on that graph that we looked at earlier of agility versus stability, I like to call this the startup mode. Things are going super fast, and it's awesome that people start utilizing infrastructure as code, but it isn't exactly stable quite yet. So not a problem, you think. We can fix this. We really need to be doing most of our work in version control. More importantly, we probably shouldn't be executing anything on our local system per se. We should be doing most of this in CI/CD. Maybe there's a machine user or something that's operating Terraform on our behalf. And this is about the time that most people start investigating Terraform Enterprise. Maybe they're implementing workflows in their existing CI/CD pipelines, or they actually start leaning on something like Atlantis. And in this talk, I'm going to talk a whole lot about Atlantis. It's because it's the thing that we're using at DoorDash. If you're not familiar with Atlantis, it's actually super slick. It's dubbed as this Terraform pull request automation, but put simply, it's GitOps. Essentially, everything that you would be doing on your local system, you're now doing in your version control system as comments. So anything that you would normally be executing in a CI/CD pipeline is actually like plans and applies and things like that would be happening as comments in your version control system. And this is important because by this time, it's very likely that you've restricted some of your engineering access to your cloud provider. So they can't do plans or they can't do applies on their local system anymore. So we sort of force people to go through the Atlantis workflow at this point. And this is what I like to call the looks good to me era. And I want to show a little bit what that workflow looks like. So basically, to start, the approach is identical, right? An engineer writes a security group, but the big difference here is now that we're preventing folks from running applies locally, since we've locked down the permissions, an engineer pushes up their change. They push up their change after doing a format and a plan locally up to version control, giving all that access to Atlantis instead of the engineer. They open a pull request. They explain the nature of their change. This isn't a really great example. I just said trigger Atlantis in this case, but they explain what their change does. And then something really awesome happens. Atlantis runs a plan off the latest commit in that branch and then outputs that plan right there in a GitHub comment. So now everyone in the organization or everyone participating in that PR can see exactly what was changed in the config by who, And what Terraform shows exactly what's going to happen, which makes reviewing this very easy, since I can see the config and what's going to change, which leads to the next step, which is an engineer requesting an approval. And the approver says, okay, yeah, this looks good to me. I'm going to go ahead and give this a thumbs up. It doesn't look too crazy. I looked at the config, I looked at the plan. We can go ahead and apply this. So they do that. And then once something's approved, the engineer has to go ahead to run an Atlantis apply, as you can see above, as a comment. And then Atlantis executes the apply on our behalf and then outputs the output of the apply as a GitHub comment, and then automatically merges the pull request. Now, this is awesome, but there's definitely a lot of pros to this approach. In the looks good to me world, we have, when we're using something like Atlantis, the approach is extremely collaborative. Engineers can actually finally participate in an official approval process. It's auditable, it's accountable. We have a clear picture of who did what and when. And additionally, now we have this new data point of who approved this thing, right? And we can be confident that our config actually reflects the state for the first time, since the two are so closely tied together in the new version control workflow, as we're confident that there are no applies happening outside of Atlantis. Now, the big con to point out at this point is now we've introduced this brand new bottleneck, right? It's more code reviews, which equates to more engineering hours spent doing approvals. And as the org begins managing the infrastructure, velocity decreases. So in the looks good to me era, I like to, or the everything in version control approach, I like to call this the slow and steady quadrant. It starts out fairly agile. So on the agility axis, it starts out a little higher. But as you start introducing more infrastructure, if you're not scaling your team with that infrastructure, the code review bottleneck will begin weighing on you, eventually slowing your ability to deploy quickly. But obviously, there's that great trade-off of knowing that you have stable infrastructure. So how do you get both, right? So you start thinking to yourselves, great, I'm a full-time pull request reviewer now. My team's doing tons of daily pull request reviews for the whole org. How do I get out of the job of just doing reviews? And your next thought is like, how can I automate this? And then for us, this is where Conftest came in, and more importantly, how it solved a lot of the issues that we had with some of those previous approaches. But before jumping right into Conftest, it's important to understand policies and policy enforcement. So a good way of thinking about our policy enforcement are the things that we're actually looking for when we do pull request reviews. We're trying to spot things that are violations to our business logic or our internal policies, things like, is this engineer going to accidentally open a security group for a production database to the whole world? Are they going to blow away my production Kubernetes clusters? These are the things as humans that we're looking for. And we know as engineers that these things can very likely be automated. And about this time, people do some Googling and they find this thing called OPA, because they're looking for a way to describe these policies. And they discover OPA and they say, oh, this is a policy engine that allows us to use a single language for describing policies across different services. This sounds like a perfect fit. Though OPA itself isn't exactly designed for our particular use case, it's mostly used in Kubernetes as part of an admission controller. And by design, its primary use is for server-side services. So it doesn't really have the end user in mind, or sorry, the local testing or CI/CD, CLI workflow in mind by design. But by contrast, Conftest is designed specifically for this, and it was built on top of OPA with the primary intention of being ran in your CI/CD pipelines or even locally for testing policies against some structured data. It was designed to focus. It was if you're not familiar with Conftest, I highly suggest checking out a talk from KubeCon last year by Gareth Rushgrove, where he talks briefly about OPA and Conftest and compares the two and shows some use cases for using Conftest, which is really awesome. But basically, it's designed to focus on testing data against policy assertions in a very, very CLI driven way. But the important things to know for this talk are that it's designed with the purpose of supporting folks in the local testing manner, like I said. It works really great with Atlantis in our setup. It supports more than just HCL and Terraform. Although for this talk, we're just going to be talking about Terraform plans in the form of JSON, though it does support a bunch of different types of structured data that are supported by OPA and subsequently Conftest. And then lastly, if we're writing some policy assertions, we're going to be writing them in Rego. And if you're not familiar with Rego, I highly suggest just like digging into the docs or checking out the Rego playground, because it's a really awesome place to start experimenting. Cool. So let's take a look at like what Conftest gives us, right? So Conftest does a few things that are centered around the user, right? It allows pulling and pushing of policies, validation. But for us, the main thing that we're going to look at today is the test command. Mostly testing, like I said, mostly testing the output of our plan against a set of policies that we have in a directory in version control. So this is how it started for us. At one point in time, we had a bunch of teams that were onboarding to Kafka, and security wanted to be involved in all of the approval process for applying any infrastructure changes in that repo. But quickly realized there was this burden of doing an approval for each Kafka topic. It was just too much. And quite honestly, they didn't care about the pull request plans and replies that only included Kafka topics. So they asked us, is there a way that we can just whitelist Kafka topics? So if that's the only thing that's changing, we don't need to do an approval. And this was basically the first policy that we wrote. Essentially, we had a resource whitelist. We checked resources. We checked our plan for resources that weren't no op. And then we checked their type against the resource whitelist. And if it was more, if there was resources that were changing that fell outside of the resource whitelist, then we knew that those particular resources weren't pre-approved and we were going to require an additional security review. And then here's what that looked like when we ran it locally against the plan in JSON. Basically, in the case of this particular plan, I was also managing a security group. And so we would get a non-exit, we would get a exit of non-zero, and we'd have an output that said basically, AWS security group is not a pre-approved or a whitelist resource, right? Of course, you can do way more complicated things with your policies. Maybe you want something like ensuring that CIDR blocks never have an argument that's set to 0.0.0, because maybe that's way too open for your org. But basically, the sky is the limit for writing these policy assertions. So you may be thinking, great, but how do I add these to my pipelines, right? Well, there's actually a lot of support. Your first option is using Conftest as part of a GitHub action workflow. The way I imagine this looks is that you would be using the GitHub HashiCorp, GitHub Terraform actions that already exist, and then you would be outputting your plan in JSON and then passing it to the Conftest GitHub action, which, like I said, already exists. Or maybe you're adding the Conftest step as part of your CI/CD pipeline sometime after your Terraform plan. Circle CI, I'm calling out here specifically because they have an orb for Conftest that you can use. Or you can do what we do and just create a custom workflow in Atlantis that is part of your plan step where it outputs the plan as JSON and then takes that plan and then executes that plan with a wrapper script again using Conftest. And it works super well. So now let's assume that you get the CLI running at this stage in your pipeline. What are some quick recipes for success that might provide the biggest bang for your buck? So I kind of gave away the first one. Perhaps the easiest way to get started is to whitelist a few resources you aren't concerned about. Like I said, for us, this is the way that we got started. We've whitelisted Kafka topics, but let me just run through exactly what's happening here. We had our resource whitelist. We checked to make sure that any of the resources that were changing and their types, and then we check it against that whitelist. And then obviously, if the count was greater than 0, we would throw a deny and say this is not a pre-approved resource. Then we learned this really awesome thing. We took all of the learnings from that first recipe and we thought, well, what if we could do something with a bit more general abstraction, right? Maybe one that covers a collection of resources with arguments and attributes and logic that we like explicitly define. And then we thought this is a great fit for Terraform modules, right? Where I can actually do something like this. And it looks very similar to the first recipe, but the big difference is that we're checking all the resources that are no-op. And then we split here to get to ensure that this is a module. We split the address, say, is this a module? Yeah, it's a module. Then we look up its source. Once we have the module source, we check to see if it's in the whitelist. What I really like about this approach is that it allows us to encourage, I guess a better way of putting it is there is no better incentive to getting your developers to use use Terraform modules than telling them that their pull request reviews will go much faster, in fact, or require absolutely no review. Because in this world, we can have a release that we have a release or a branch that we're very confident in and that we control. We control like the tagged S3 bucket module in this case. We can see everything that's going on in it, and we can say, okay, great, this is a pre-approved module. You can use this, and as long as developers are taking that route, they won't have to have the approval. And it encourages folks just to keep things dry across the code base. So rather than just writing Terraform inline and wherever your infrastructure repo is, it's very likely they'll start leveraging these, leveraging external modules and asking you to approve them. And then you can just keep a running module whitelist of pre-approved modules, and everyone wins. Now the third one's basically a good scenario if you're fairly confident in your engineering org and you're mainly performing code reviews because the change is complicated, or you just want to prevent a bunch of deletions, or you want to prevent a bunch of creations. And so this is recipe 3. Is this engineer about to delete a bunch of resources? Maybe we're only like trying to do an additional approval if it if there's more than 10 deletions. So this one's extremely simple. We're checking the actions to see how many actions, we're checking the resource changes to see how many are marked for deletion. We're getting the address of those. We're actually not using it in this case, but we're counting those resource deletions, and we're saying if it's greater than 10, then we want to exit non-zero. So anytime we're deleting more than 10 resources, require an additional, fill the policy, which you'll see here in a bit that will actually require an additional approval. Cool. So those are the 3 recipes I wanted to just briefly share. I wanted to show a demo of how this all works in practice, though, because it's easy to talk about the policies, but I wanted to show basically what an example setup looks like. More importantly, how we're managing our infrastructure, what we're using to run Conftest test, how we're surfacing the output or utilizing the output of that test, and yeah, exactly, and what we're doing with it. So here's our setup. We're using Atlantis with a custom workflow that executes both Terraform plan and a wrapper script for that plan output. We're using GitHub status to determine the state of a pull request and whether or not it's mergeable. And we're using this little slick service called pull approve, which allows us to determine how we select specific approvers for a pull request based on maybe the status or files that were changed. But you could do this a number of ways, but this is just how we implemented it. So the first thing we need to look at is obviously in the Atlantis.yaml. This is the config for Atlantis. And basically, the first thing we're checking is to ensure that before we allow anyone to apply, that all of the other status checks are successful in the PR before we allow apply. That's what these apply requirements are. The other thing worth pointing out is that we're actually doing initialization. We're running a plan, and then we're running that same. We're taking that plan, the plan file. We're doing a show to get it in JSON and outputting a JSON file, and then we have this low key script here that's just called root/opa.sh. I really wish it was called conftest.sh, but it's called opa.sh. And essentially, we're pre-baking our Atlantis image with this script already in the container. And a little bit about what that script does. Well, it looks like it does a lot, but it really doesn't do a lot. The first thing it does is it checks a particular directory and the repo for policies, and then immediately calls a GitHub status function to set the status of those policies to pending. It iterates over that directory and then runs all of those policies against, it runs our plan file against all of those policies that have been defined, and then sets the state to either success or failure based on the exit code, and then updates a GitHub creates a custom GitHub status for each of them for each different policy name. The way it does that is using this GitHub status function, which is actually really great because Atlantis has most of the environment variables that we need to make this work, like the GitHub token, the repo owner, the repo name. Basically, most of the things we need are already there, so we can make a API call to GitHub without any issues. Cool. So the second thing, make sure to miss anything. Second thing is our pull approve. The first thing we want to do is we want to make sure before we determine who should be approving our PR, we want to check that the plan has finished. So we say if it's still pending, we just say that it's waiting for the Atlantis plan to finish. We have an additional approvers for some scenarios. So in this case, we have some admins that will do some approvals for if the policies have been violated, and then the conditions for whether or not those that additional group is an approver, or if they try to change this particular file to modify who's an approver, who's not an approver, if they try to modify our actual policies themselves, or if the this is the real important one to point out, which is, or if the custom status that we've defined has failed. So this can be a lot to take in. So I think what I'm going to try to do is I'll try to just do a demo real quick. Let's see if I can just do it here. I'm not going to try to switch between my text editor. It used to be called Conftest example. I'll do that later. Cool. So here is our Conftest demo repo. Like I said, we have this policy here in the Conftest PE whitelist rego. And we're checking for module changes and resource changes. And this is a combination of both the resource whitelist and the module whitelist example I showed earlier. The other thing, let me make this a little bigger. The other thing is basically what I've already showed you. We have these custom status here that's checking if it's failed, and if it has, make sure that this group also has to approve. Otherwise, just have this person or this group approve. And then obviously the Atlantis.yaml, which is calling that opa.test.sh script. Cool. So we have some Terraform here. Right now I have this module that I have commented out. I don't know if you saw it earlier, but one of our policies actually had a particular version here, version v.2.0.2 that's been whitelisted. I want to show you what happens if we use that ref, and I want to show you what happens when we don't use that ref. So let's get started by creating, I hate doing this in the UI, but it works for what we're doing. Okay, cool. So I'm going to create a new branch. I'm going to just, that's a fine name for a branch. And then I'm going to open a PR. And so the first thing that's going to happen is pull approve is going to say it's waiting on the plan. Atlantis will plan. And then once part of that plan, obviously, is it's going to be executing Conftest on the hood for us via the wrapper script. And then it creates this policy check and says, yeah, everything looks good. And if you, this shows me, we only have one group pending right now. And that group should just be me. If I look over here, I'm the only person. And that's because our policy succeeded. Now, let's go back and let's modify that to use an older unapproved version and see what happens. So if I go over here back to my example and go to modules, and then I set it to say an old version that maybe this has a bug or something and we don't want people using this anymore. I commit it directly here, and then we see what happens. Cool. So Atlantis is planning again. Pull approve is waiting for the status to be reported. Cool. So now we have a policy violation. As you can see, now the OPA policy check has failed. It says the plan's still in progress. That's not actually right. There it goes. And now we have two groups pending. I wanted to show the output of the plan too, because it actually tells you exactly why it failed. It says this is not pre-approved. Yeah, and if we jumped into pull approve, we could see now we also have PE admins. Cool. I don't know how much time I have, so I'm going to stop sharing that and get right back to where I was. Cool. Great. So as you can see, there are a lot of pros with Conftest. We get the agility that we want through an automated policy checking. We have the same audit trail that we had before. We have a clear change history. And now we have extra reliability, knowing that our codified policies won't let anything accidentally get deployed without a good approval. There is, however, the con of setting this up, setting up the policies and the workflows. But hopefully this talk has inspired you to like take a look at Conftest and get started and start small. And just know that any effort on the front end will quickly pay for itself. So, which means that we can safely put Conftest or OPA plus Terraform in the top right quadrant and call it Supercharged, where our infrastructure is now agile and stable. Which effectively means I can drink a nice cup of coffee in the morning without hundreds of co-review requests.